Hello guys, I hope you're well. This is Sig and I'm back with yet another video, and today I'm feeling in a spooky Halloween kind of mood. This is October that I'm recording this video in. Halloween is getting close, be upon us, so I figured this would be the best time ever to look at the so-called GOTTH stack. A scary web application stack that uses Go, Templ, HTMX and other things we'll talk about in a second. And this video will then show a little example of how we can bring those things together, how we can build an application using this stack. So we can start by talking about what the GOTTH stack is. So obviously the first two letters stand for Go. So Golang is the language that we're using in this stack. Golang is a language that I cover on this video all the time. The next one is Templ. So Templ is a templating language that works with Golang. So there's a whole lot of information on templ.guide, but essentially it's a way to define things like HTML templates and then interject Go code into it and be able to render things easily from Go. The other thing is Tailwind, which is a very, very popular CSS styling framework. It basically uses class names to put styles on things. And finally, HTMX. And HTMX is a hyperscript markup language library that basically allows you to use declarative JavaScript on your HTML tags and also serve HTML from web endpoints, which we'll be getting today. So let's have a look at what we're going to be building. Since it's Halloween, I built this little really silly demo application that showcases some of these technologies. So here we are. It's Sig's Halloween party. I'm not a graphic designer, so please don't be too upset by the way this looks. I just quickly threw this together. And what we have is some simple stuff down here, and we have a big splash screen. It says, "Welcome to Sig's Spooky Spooktober Halloween Party Planner," right? And then there's a bit of text about what this is. And then it says, if you're brave enough, you can continue. And then you can say, "I am brave enough." And it says, "Do you really dare to attend?" And we can fill the same and say, "We're going to attend." And we're going to say, put in our email, and we're going to sign ourselves up for the scary party. And then it says, "Foolish mortal, you've been added to the party. Good luck." And here are the people who are going to the party. So it's me up here at the top, and then Frankie at Stein just signed up as well. All right. So that's basically what we're going to be building. And it may not look like much, and it sort of isn't, but it showcases all of the technologies that we're going to be using. So all of this functionality that we just saw, this going through, this changing, it's actually using HTMX under the hood, and all these things that we're seeing are being served by Templ and Tailwind. So let's have a look at some code. What we have is I've created a pre-configured web application template, and this web application template follows the usual structure of my Golang projects. So if you are completely new to the channel, I have loads of videos on Golang that essentially walk through how I structure my applications, what I typically use, and the sort of tooling that we use. And one of the tools is a makefile, for example. So for this project, if I bring up a terminal, you can actually run make help, and I hope you can see that okay. And you'll see that there's quite a lot of make targets in this project, and that's because we have some utility things that we're going to use. And one of the utility things is the so-called air build system. So when we're working with Golang and with Templ, it can be really handy to have a sort of watch build system that essentially just goes ahead and recompiles your source code when you change your templates or when you change your Go source code. Because we're going to be changing templates, and those templates go generate some Go code. It's quite nice to have this running in the background. So what I'm going to do is I'm going to run make watch, and that will actually run air, which you're seeing in this terminal here. And this will basically just run now and recompile our source code. Now, right now it's complaining because obviously the application that we just saw is on this thing on the same port. So it doesn't like that. But you could basically put this aside. I'm going to put this out of view. And it's still running in the background here, even though you can't see it. And this will just recompile our source code every time we go. So let's have a look at what I've prepared for this example today. So I decided to do a little bit of preparation for this video, just because we're going to be doing a fair amount of stuff, and I don't want it to be a 2-in-1 video. So I've created some simple things that follow patterns that we have done on this channel many times before. So for example, we have a guest store. So if you look at the guest store, which is defined inside store and guest too, it's a very simple store that just uses an in-memory map. So this is replicating a database or emulating a database. Basically, this is just so we can get going. Obviously, in production, you wouldn't want to do this. Most likely, you'd want to use a real database. We're just using this to spoof the database. And we've got some very simple CRUD operations. We've got add a guest. A guest, as you can see, is a struct up here, which is just a name and a string. And we can add a guest, and then it says it needs an email, and it adds it to the key if it doesn't already exist. It adds it to the map, if it doesn't already exist. And we can also get guests, which returns a slice of all the guests. And then finally, at a utility function, we can decode a guest. So if we have a JSON representation of a guest, we can decode it into an actual guest or throw an error if we fail to decode it. So this is a little guest store that we have. Again, it's not really that relevant for what we're doing. This is just really to get us started. And more interestingly is our server. So I created, in much the same vein, I pre-prepared a HTTP server. So this is using a very simple setup for an HTTP server that was introduced in Go 122. Again, all this source code will be available on GitHub, so don't worry too much if you're finding it hard to follow along. You can use this as a starting point, and then we can build on top of this. But essentially what it is we are using dependency injection, which is a topic that I've covered on this channel quite a lot. And I can post the card in the top to a video about dependency injection to basically inject a guest store that can add guests or get guests. Then we have a server struct, which is a struct that holds onto a couple of things, including a guest DD, which is our guest store, and an HTTP server pointer. And then we have a new server constructor, which goes in and actually constructs a new server. Okay? With the new server, we can call start. So what does start do? Again, a couple of things just to set us up is it creates a new server mux. This is part of the Go 122 HTTP server setup. Then it actually adds a file server handler. So we're serving some static files. That's because you want to serve some style sheets, some CSS. You want to serve a couple of images, so on. And then this is where we actually define our routes. So I'll just put a comment here, define routes. And you can see as of Go 122, you can define routes using an HTTP verbs. You can say like get, post, put, patch, whatever you want. And then a route, and this can include wildcards and templated routes as well. And then you specify a handler. And we'll look at the default handler in a little bit, but let's just continue walking through this server implementation. So this server implementation spins up a new HTTP server listening on a specified port and passes in our handler as our router as a handler. And then the only thing we have left is we have a channel here that allows us to listen for an interrupt signal so that we can stop our server by passing an interrupt signal. And then we have a go routine that actually makes the server listen, and then we block on the channel here waiting for the signal for it to stop. So I know this is quite a lot. Again, the code will be on GitHub. You can read through it there if you need the time to read through and understand this. But essentially, we're setting up and starting an HTTP server. So when this function returns, we will shut down. Or when this function reaches this block here on the stop channel, what we will have is a server listening on the port, right? So the final thing we can look at is the default handler, a very simple handler. All it does is it writes some HTTP status OK header, and then it writes some text. And the text is my spooky Halloween party. So let's see if we can actually hit this. So what I'm going to do is I'm going to stop the other server, which is still running. And then I am starting air here again, just to make it read bind. And I'm going to hit the same server. And here we go. My spooky Halloween party is being returned by a default handler. Cool. What we haven't talked about yet is Templ, right? So let's actually start implementing a little bit of Templ functionality. So what we want is a couple of things. We want to include some resources like HTMX and so on. And we also want to just render some HTML, and then we want to inject some Go code into that HTML and present it to the screen. Great. So I've created a templates directory underneath internal. And let's go ahead and create our first template. So I'm going to add a new file, and I'm going to say internal templates, and I'm going to create base.templ. So the way Templ works is you use these .templ files, and then you have a loop which I baked into the make target, which watches for these Templ files, compiles them into Go code, and makes them available to your program. So let's start with the very, very first template here. And this first template is going to be quite simple. We're going to say Templ, and let's just call it header. And it's just another function. So this is essentially Go code. And we're going to implement a header. And I'm actually going to copy a predefined one to save me a bit of typing. So bear with me a few seconds while I fetch that. So I'm going to go ahead and paste in some HTML code. Now, this is just HTML code. It has the head element, it has a title, so on and so forth. And then it pulls in a style sheet located at static CSS style.css. So this is interesting because we added that file server handler to our handler, right? If you remember, to our server. So we should be able to serve static files from the static directory. And style.css is something we'll talk about in just a second. But before we do, let's have a look at this line here. So we've got header, and then we've got title, and then we've got these curly brackets, and it says title. So what this will do is it will look for a Go variable that's been passed into the template and try to resolve or print back Go variable. So because we have a variable there, we need to pass in a title. So let's pass in title string like this. And this will actually be a complete template. Now, let's make it a little bit more interesting. And let's add another template. And this one, we're going to call layout. Let me go ahead and create a new template, layout. And this one, we're going to pass in another Templ component, or a Templ component to render inside it, a title, and then we can actually call in or pass in another template like so. So we can actually include a sub-template like header inside layout and render it like this. And as you can see, we can pass title into that header to basically pass title into sub-templates. Now, one thing you might notice for the more eagle-eyed people is that this way we're probably never going to expose header. So we can actually go ahead and make header private by turning it into a lowercase name, right? That will make it private in Go. So let's do a couple of more things inside layout. And all we're going to do is we are going to add a body like so. And then inside body, just like we did with our header, we're going to say add contents. So this will basically render out whatever template component we passed in as the content. Cool. Let's go ahead and save that. Now, we just saved this. Fine. So error actually triggered. If you want to see, there was error, right? It triggered and said changed, all good. But something else happened as well. Let's have a look at templates. At a glance, we only have base.templ. But if I go and show hidden files, so these are files that are in my getignore, you can see there's also a base.templ.go. So this is a generated Templ file that was created by Templ to basically go in and capture all the things that I just coded up in Templ and created a Go file out of it. So what this does, and what is really cool about it, if I go ahead and delete this file, is every time I change something in here or save it, it will actually go automatically and create that file so that the file and the compiler template is ready for me to use in my code. And this is why we use error in this project to actually facilitate that. So error again ran when I saved the file and actually generated the template. And so this is a pattern that we can use to define all of our templates to really make working with this much easier, make our feedback loop as developers much faster. The other thing we've done is we've pulled in static, or we've pulled in this style.css. But what is style.css? If you look in here, there's custom.css, where I have added some custom stuff, which including some Tailwind includes. And then there's style.css. So what we have is we use Tailwind in this project. So what we have is we have a make target that is actually Tailwind watch. And what this will do when you run it, and you kind of leave it running, and you can close it and leave the running in the background. That's what I typically do. This is a common pattern in Tailwind because Tailwind is kind of a compiled style sheets manager. What this will do is this loop will go through all of our template files and all our all of our template files, and we'll find any classes that we use, any Tailwind classes that we use, and it will compile the CSS required to render them into style.css. So without having to worry about anything, we can essentially know that Tailwind will constantly be updating style.css and make it available to our server. Very good. So with that in hand, let's go ahead and change this a little bit. So now right now we've got this, right? But we actually want to change this. We don't want to just return my spooky Halloween party, because if we go to the browser and refresh, we're still just returning man. We want to use our template. Now, if we just use it as is, there's a couple of ways we can do that. First things first, we want to pull in templates, right? So here's templates. And one way of doing this is we can say layout, which is the template that we just defined, right? In base.templ. If we go in here, we've got layout, which takes a component and a title. But we don't really have a component to pass into it yet. So what we can do for now, which is pretty bad, is we can pass in nil, and then we can say home, right? And then the template has a render function, which takes a context, which we can pass from the request itself, and the target response writer. Let's go ahead and see if this compiles. And spoiler alert, it did compile. So let's go to our browser and refresh. And suddenly the screen went blue. Okay, why did it go blue? Let's go ahead and inspect what's going on. There's a couple of things going on here. But if we look at our inspector, we can now see that there's a body, there's a main, there's a head, and this is actually the header that we pulled in, right? And suddenly our screen went blue because we pulled in style.css, which has a background color of blue. And suddenly we're in business, right? Our template is working, our header is working, and we can now use Templ to build out our application. Now, in the interest of saving time, we're not going to build the full application with all the styling that you saw at the start of the video. We are going to cut some corners. We're going to show you how all these things work together to create the application, and then you can come up with your own cool Halloween styling to actually make it look the way you want it to look. And again, the full source code for that example is available on GitHub, and I'll put the comment in the pinned. I'll put the source code link in the pinned comment below. So let's get going. We need another template. Let's go ahead and create another file, and we're going to put it in templates, and we're going to call it home.templ, and this will be our home page. So again, importantly, it goes into package.templates, right? So it's in our templates package. We're just going to find another template here. We don't need to pass it any parameters. Let's just create a load tester. Let's go ahead and say my Halloween party, right? And we can say, I would like to invite you to my Halloween party. There we go. And let's just leave it like this for now. And we'll actually create, just for fun, let's create another div down here. And let's call that div, let's give a div an ID of guests. So maybe we want to render out the guests that are currently invited to the party. That'll be interesting to do, right? So this is our home template. All right. Again, you saw straight away when I said that it went ahead and actually compiled the GOTTH file. So this is now available to our server straight away. So we can go back to our server, and rather than passing no here, let's actually pass in that template. So let's say home template equals templates.home, like so. And then we're going to pass in home template like so. And if we now refresh, you won't really see it because our background is black, but we can actually go back and change that and say, give this a class. So let's say this is text 2XO, and let's say text white. And we'll do the same down here. Text white. And let's see if that works. And if we now refresh this, it didn't actually work. Nice. There we go. I had to refresh it properly. It's now white, and we can now see my Halloween party. I would like to invite you to my Halloween party. And there's 30 not any guests, right? Very good. So it may not look like much, but actually there's a lot going on here, right? So let's just take a little step back and just walk through what we have, because we have a server.go, which has a single route at the moment, which is the root route, which is here getting the root. It also serves the static folder to serve our style sheets, basically. So that's what the server does at the moment. Then we have two Templ files with multiple templates. We have a base.templ, which creates a layout and a header template. The layout is a top-level template that can take in a child template, which you will render inside this main section. It also takes in the title, which it passes into the header, which the header in turn displays as the actual title of the application. Again, we could do something like this. Say, Sig's Halloween, right? Do something like this. And the other thing that we have is we have a home template, which is the one that we render at the home location, at the home route. And that just prints out this stuff. And let's actually make it a bit more interesting. And let's do a break here and add another header, and which we'll also make white. And we'll say guests attending, like so. Okay. Now, another thing that we have, which we haven't talked about yet, is the actual main.go file. So there's not a whole lot going on here. This is very similar to what we're used to seeing on this channel. But what I have done is I've actually created a placeholder top-level guest, which is myself. So we've got Seal, who's going, and we've got this nice fake email, which is definitely a real email. And this is a guest that we actually add to the store. So this guest is just always there, since I'm the one hosting the party. The only other thing we do is we create a new server, and then we call server.start, which we talked about, and we run it on port 9000. And you could change this to be a port that you inject from an environment variable or something else. So what do we do now? Well, I think we should start by adding a guests endpoint. So let's go ahead and go to our server, and let's implement a new router, and we're going to create a new handle function, and we're going to add an endpoint we're going to call guests. I'm going to say get guests handler. Okay, so we're now saying there's going to be a route. If you HTTP get this endpoint, it should forward it to the guests handler. So let's go ahead and implement the guests handler, like so. So get guests handler, and we'll go ahead and close the curly brackets. And what do we want to do? Well, what we want to do is we want to fetch all the guests that we currently have in the store. Let's go ahead and do that. So we'll say guests error, and let's say store, get guests, right? And I will say, if something goes wrong, we can actually we'll handle that in a second. You say handle error. But if it doesn't go wrong, what do we want to do here? Well, we could just return the guests as is, right? That could be a starting point. We could maybe that would be an interesting starting point to start with. But I think what would be even more interesting is to actually use Templ, because this really will show how Templ works and how Templ can really interface with Golang. So let's go and create a new template and say internal templates guests.templ. There we go. And we're going to do the same again. We're going to say package templates. And we're going to create a new template, and we're going to call it guests, like so. And this is just another function. But what's really cool is that even though we're in Templ and we're writing this Templ file, it still is compiled down to Go, which means that we can actually do something like this. We can go ahead and import our store. So if we go to our server, for example, we go to the top, we can actually go ahead and import this store into our Templ file, which I realize now that I didn't save, which is very simple. Okay, so let's go ahead and create that again. Apologies for that. So we'll create guest.templ. There it is. Very good. So we're going to import our store. And now we can literally say, this will take a slice of guests. I'd say that. And what's really cool here is that this is Golang code, right? Basically, although it's Templ. But this is a Golang struct that we created, we defined inside store. We're importing store as a normal Golang package, and we're using it just like a real Golang thing. So let's go ahead and see if we can actually, or how we can actually interface with this, since this is a slice. And the answer is, it's really very simple. Because Templ is essentially Golang when it comes to things like this, we can literally do something like this. Let's create a div, the top level div, and we'll call it guest list just to show you how this works. And then we can literally just do a for loop like we would normally do in Golang. So we can say range guests, and we can actually print out each guest. So let's go ahead and do that. So we'll create a placeholder div like so. Let's create this up a little bit. And since guest is a Golang struct but has two fields, we can actually print them out. So let's just try that for now. And we'll do text for it again. And we'll use the curly brackets and we'll take guest.name. We'll go ahead and close that. And then just for kicks, we'll do the same with the email. Cool. All right. So what are we trying to do now? Let's see. Let's go back to our server. We have our template now. It generated guest.Templ. Let's go back to our server. And we are going to go into our guest handler. And we've now got the guests that we want to render. So we can do a similar to above. We can do guest CPO equals templates dot guests. And then we can pass in guests as a parameter that it needs. And this will render the template based on the parameters that we gave it here, based on the input that we gave it here. And then once again, we can actually go and render the layout if we wanted to. Well, that'll fully change this, but here we go, render and pass in guest CPL here, right? Like so. So let's go ahead and compile this and see. So I can tell you from looking at the side of my screen that it's currently complaining, and I will show you a little bit. So with the pull in air here, you can see it tried to compile, but it's saying undefined store but get guests. So clearly I've made a mistake, and I need to remember what I actually named that function, which I think is actually just guests. No, get guests. I thought it was get guests. Okay. So it's obviously not stored. It's on the actual guest DD of our application. So now I compiled, we can go ahead and refresh this. We've got guests attending. Let's go ahead and see if we can hit guests. There we go. So we hit guests and we actually got seal and we've got Maino, right, printed up. Okay. Now you might say this is cool, but this is all Go and Templ for now. So how do we do this with HTMX? Where does HTMX fit into the picture? Well, I will show you. Let's go ahead and add some HTMX functionality to this project. So if we go to our ACE template, we can pull in HTMX or any other JavaScript library simply by referencing it down here. Right, so here I've gone and added a CDN for the HTMX library, the script, as well as an extension that is really handy for dealing with JSON encoding of forms when you want to send off a form. So if I go ahead and say this, we can refresh the page and nothing would have really changed, but we have actually added a HTMX dependency to our project. And what we can do now is we can actually try it out. So what do you want to do? Well, let's do two things. First of all, let's change our server. Rather than rendering the full layout, let's actually just render guests on their own from this endpoint. So HTMX is all about sort of trading out byte sizes of HTML that your server renders, are rendered on the server side, and then sent to the front end on demand, right? So HTMX is all about essentially trading those snippets of pre-rendered HTML and then replacing them on the DOM or on your web page when you want to do that. So if we remember our homepage, which is here, we have a guests attending, which is currently blank. And if we now go to guests, if we refresh this, and if I save the server and go ahead and fix this, you can see it's now no longer blue. We've just got this because we're no longer pulling in the whole layout. So we don't have our header. We don't have HTMX or anything. This is literally just HTML. So what we want to do is in our home template on the home page, we want to go in here and we actually want to replace what's in here with what that endpoint returns. So how do we do that? Well, The easiest way, which is very easy, is to literally use a beta annotation that HTMX exposes called HXGet, which is at guests. So let's see how far we get with that. So here we are. This is our endpoint, all good. Let's try to go to our homepage, guest attending, and it's blank. Why is it blank? Let's have a look. No errors in the console. That's usually a good place to start. Any errors in our code? Don't see any errors. So why is it blank? Well, there are actually a couple reasons why this could be the case. So let's have a look. We are pulling HTMX, but okay, so I think the problem is that we need to specify a trigger above when this should actually happen. So let's see if when we add an HX trigger load, if we can actually get it to load. And there we go. So now it's actually loading. So the problem there was that I had said for it to go and fetch whatever HTML was returned another guests endpoint, but because this is just a give and not a button or something that has a natural trigger like clicking it, you need to actually specify when you want this to happen. And I had now put HX trigger load, which is when this element gets loaded, it immediately goes out and fetches this data. So now I've actually got guests attending. So if I refresh the page, you can see that there's maybe it's very hard to see, but there's a slight delay in when this actually appears. And that's because if we go to the Never tab, you can see that HTMX has actually fired off a GET request to our guests endpoint. And you can see that that in turn returned a guest list, so on and so forth, with the two guests or the one guest that we have. So all that remains for us to do now is to actually add the ability to add another guest. So let's go ahead and do that. And we can go ahead and create an input here. Well, actually, let's go ahead and create a form. That might be better. And this form is going to have a target, which is going to be guests as well. We'll implement this in a second. And for now, let's just create the form, maybe create two inputs. So we'll create a text input for the main input, and we'll say main. And let's not give it a standard value. We'll just leave this as an input. And then we can actually go and replicate this. And this has a now your email or a name of email. And then we'll create a button, should be of type submit, which will say join the party. There we go. So if we refresh this now, we have those things. They look terrible, granted. And the button, that's just for our own sanity's sake. Let's add a little bit of text to the bump. Let's text white, and we'll say, e.g., it's created. Why not orange? Orange is fun, isn't it? And we'll say lock as well. Let's see if that makes it a little bit better. Well, not really, but it'll do the trick for now. And so what we need, right, is we've said there's a target, and this is a form. So by default, this would actually post something. So let's have a look at what we need to do to actually make this thing work. Now, if we go to our server, so we'll go back to our server, what we want is we want a way to actually post something to guests. So just like we did before, we can go in here and we can say post. So now we're saying there is a handler that should be called when a post request hits the guest's endpoint. So let's go ahead and implement the add guest handler. This is just another handler. Add guest handler. And kind of like before, we are going to return some HTML. And we can do a couple of things here. So we could obviously return some kind of status code saying like, yeah, you've added a guest, for example. But we can also add the updated guest list or return the updated guest list after this event has occurred. So how do we do that? First of all, let's see if we can actually add the guest. And I think if you remember from our earlier, when we went for the store, we have a helper function inside our store, which is decode guest. So what we can do is I'm going to copy some code in here and walk you through it. So first of all, we're going to fetch whatever's in the body, which we assume to be a JSON encoded guest. So basically a value of name and email. And then we'll throw out an error if something goes wrong. And in fact, while we're here, let's just copy this up here to handle the error up here and say error when fetching guests, right, in case something goes wrong. And then we call decode guest. Now, if the code guest fails, we throw another error and say there's no guest in whatever payload you gave me. That was nonsense. I can't work with it. But if it succeeds, we can do another thing, which is call add guest, which again is from our store, right? We had them add guest. And again, this is a lot of kind of just boilerplate code, but we're reading the request body, then we're calling decode to actually get the guest struct, and then we're calling add guest. And finally, if you successfully add a guest, so we throw an error if we don't, what can we do? There's a couple of things we can do, but let's just essentially mimic what our guests handler does, or get guest handler does, and do the same thing. So we'll fetch guests again after we just added one, and then we'll return the guest template like we did up here, like so, and we'll call render. And what this should mean is that this endpoint, after you post to it, should return the HTML of the updated guest list. Cool, right? Okay. Let's see what we need to do in our template to actually make this happen. So we'll go back to our home template. So we've got right now HTMX target, Brad. So this is no good because we need to tell HTMX a couple of things to actually make this work. So what does it need to know? It needs to know where to actually host a request to, and also that we want to use post. We could have been using patch or something, so we're going to change this to HX post. Then we're going to give it an HX target, and this HX target is going to be the ID of a div that we want the response from this request, this post request. We want to target whatever comes back, the HTML that comes back, into the target div that we're specifying here. So the HTML that this returns should be put inside this div down here if things are working. Okay, very good. And finally, I mentioned the extension earlier, which is a HTMX extension called JSON Inc., which will basically just JSON encode the values that you have inside your form to make it a bit easier to work with. And then we can also make this a little bit nicer, like so. Okay, now, a couple of things. It's complaining about some dependencies that we need to pull in. So we need to pull in IO. So IO is, I thought I pulled in IO, but clearly I didn't. So let's see what else. There we go. I think it's happening now. So if we go ahead and refresh this beautiful page, we can now try this out and say test and give it an email. And we can say join the party. And immediately test was added down there. Test 2 fails because the same email doesn't work. So our server in the background is actually telling us a spooky guest with email already exists. So don't do that. But if we change the email, we can have another guest, and you can see the guest list is automatically updating. So if we actually open an import tab and just see what the hell's going on, let's add another guest. You can see this list just keeps growing. What's actually happening is that it immediately fires off this post request. If you look at the header is post, and the response coming back is the updated HTML of the guest list, right? And what we've told HTMX is that whatever comes back into the HTML, we're going to target the guest list, right? And HTMX also has strategies for how you can, how you want this to be rendered. But this is the easy example out of an initial example. So this way we can just keep adding guests to our party, and they will keep growing to a guest list. And if we refresh the page, we immediately get the full updated guest list, and we can keep doing again, right? Now, in the interest of not making this video too long, I think we're going to end it there. But this is just the beginning, right? There's a lot of things here that we want to differently. We want to do validation of our input. We want to handle error handling, not just sending the bad request, but also you want to output to maybe an errors div if something goes wrong. You also want to potentially use a different way of storing the guests, right? And a different way of rendering the guest list. So you don't have to retouch the guest list every time. But this is really just an introduction into Go, Templ, and HTMX. And I will say this is a great stack to work with. It's a little bit annoying that you have to, have basically 2 windows open, one for Tailwind Watch and one for Air. But on the other hand, you just kind of forget about it. They're just running and they did your output while you're working. And the cool thing is that they take care of all this boilerplates to actually allow you to just crack on and build these cool templates. And Templ is so easy to use because you can use essentially Go, right? To do things like your for loops and if statements. And there's a lot of examples here of how this works and all the things you can do. And it's really very similar to Go, right? Which is what makes it so powerful. So I think this is a great stack. It's not my favorite tech stack or web application tech stack. I'll keep you posted on what that is. I'll probably do a video on that real soon. I have a personal favorite that I've been working on this year, but this is a really close second. I think the GOTTH stack, even though it has a silly name, is a really, really good stack to build modern applications in. And I hope you have a lot of fun doing so. So thank you for watching, and I'll catch you in the next one.